We have a weight attached to a spring that's pulled down 2 inches below the equilibrium position. So in other words, you're taking a string and you're stretching it out all the way down to the bottom, and then you're letting it go to see the oscillations. Assuming that the period is 1/3 of a second, determine a model that gives the position the weight in t seconds. Okay, first of all, you're starting down with the pulled down. That's going to give us a negative function. So we're going to start, it's going to be negative. Our up and down is the 2 inches they told us. So this is our -2 out front. We also started down, so that means that if you think about the graph, that means this started down here, right? That's cosine, okay? If it started here at 0, 0 in the equilibrium position, that would be sine. So that's kind of how you differentiate between those two. Then we need to figure out what we're going to put here. What's omega? What's that funny looking W? Well, we know that the period is 1/3, okay? And our period is 2 pi over b. So we're just solving for b or the omega, okay? So then I get 1/3 omega equals 2 pi times both by 3. Omega is 6 pi. So then this is 6 pi t. Now the frequency is reciprocal of the period, so that means it has to be 3 cycles per second. And we're in seconds is the reason I use seconds. So 3 cycles, 3 oscillations per second. So hopefully this helps you see how to do this. So kind of as we're doing it, you need to be thinking about the picture. The picture is going to tell you, are you sine or cosine? Are you starting down? Are you starting up? Cosine usually starts up. If we would have pulled this up, we would have started with the positive one, but because we pulled it down, we started with a negative out front. So just kind of some things to look for as you write these equations.